Okay, Math 9, here we go. We're looking at our second form of an equation for a straight line. It is standard form, and what we're looking at this time is an equation that looks like this. So it's definitely not as lovely as our y equals mx plus b. Y equals mx plus b was great because it gave us our slope and it gave us our y-intercepts just by staring at it. This one does not do that. This just gives us ax plus by plus c. Now, a, b, and c cannot be fractions in order for this to technically be in standard form, and a has to be positive. So you can have an equation that looks like this: 2x plus 3y equals 6, but only a has to be positive. So you could also have 2x minus 3y equals 6, or you could have 2x minus 3y equals negative 6. All of that is totally fine, just as long as this value here is positive. That means it's technically in standard form. So let's look at how this works. Well, standard form is exactly the same as slope-intercept form when it comes to points being solutions on the line. We have an x and a y in our equation, and we have an x and a y in the coordinates of a point. So we just plug into our equation like we would, and we solve. So here we have 3 times 2 minus 2 times 6 is negative 6. So then we get 6 minus 12 equals negative 6. Negative 6 equals negative 6. And that is a yes, I'm on the line. So same one here, we have x minus 3y equals 9. So I'm going to plug in a 1 for x and a 3 for y. But in this case, I get 1 minus 9 equals 9, which gives me negative 8 equals 9. So not overly happy about that. That is not a point on my line. So the principle of plugging in and solving is the same as it was with slope-intercept form. A couple more. So now, yeah, this is technically a weird standard form because I just have an x, but it still works. And I'm still plugging in my x value. So 4 equals 4. Yep, that works. That's a vertical line. And then here I'm plugging in negative 2 for my x value and 5 for my y value. So 3 times negative 2 plus 2 times 5, and I get negative 6 plus 10 equals 4. 4 equals 4. So yes, I am a solution to the equation, or I am a point on that given line. That is what that means. So how about graphing? Well, what we're going to do for graphing, because we don't have the slope and we don't have the y-intercept, is we're going to create a table of values. And what we can do is we can pick any point for x and solve for y, and we could pick any point for y and solve for x. But what we're going to do is we're going to always pick when x is 0, because what does that give us? That gives us the y-intercept, right? So when x is 0, we have our y-intercept, and then we're also going to pick when y is 0, because when y is 0, what do we get? We get our x-intercept. So 2 great points to have. So always good to start with those 2, and then we can pick strategically after, and I'll talk about that in just a second. So what do? Well, we set x equal to 0. So 0 plus y equals 4. Well, y equals 4. So that means that when x is 0, y is 4. So what that means is we have a point at x0, y 4 right there. So then we do the same thing, but we set y equal to 0. So x plus 0 equals 4, so x equals 4. So in this case, when x is 4, y is 0. So you can see we have 2 line dots so we could connect with our line, but we always want to make sure we haven't screwed it up. And the strategic choice to make is going to be take whatever value you got for your x-intercept and either add the same amount to it. So here we went from 0 to 4, so we'll go from 4 to 8. So that's one method. Or change the sign of whatever your x-intercept was. So our sign was positive 4, so we're going to change it to negative 4. Now, there's other points you could pick. You could pick an infinite number of other points. I always like to pick those ones because it keeps my rise run consistent. So if x is 8, I have 8 plus y equals 4. I'm going to subtract 8 from both sides. Y equals negative 4. So when x is 8, y is negative 4. So I have a point 5, 6, 7, 8, 1, 2, 3, 4, and it looks pretty good. That's why it's always good to pick 3 points at least so you know whether or not you made a mistake. We will also try though here when x is negative 4. So negative 4 plus y equals 4. I'll add 4 to both sides, and y is 8. So I now have a point at negative 4 up at 8. And again, there we go. My line looks pretty good. I did not screw that up. So you can pick your points, but always start with the 0 and the 0 there. So let's do another. We're going to start here when x is 0, when y is 0. So when x is 0, we have 4 times 0 minus 3 times y equals 12. And then 0 minus 3y equals 12. So negative 3y equals 12. Divide by negative 3, and y equals negative 4. So when x is 0, y is negative 4. So let's do that again, except this time we're going to set y equal to 0. So 4x minus 3 times 0 equals 12. 4x equals 12. Divide both sides by 4, and x equals 3. So now I'm just going to pick my next point as negative 3. I'm not going to go to 6 this time. I'm just going to flip the sign. So I'll just change my equation. And this time I will plug in my x value as negative 3. And I'll work it out. So I have negative 12 minus 3y equals 12. Then I'll add 12 to both sides. Negative 3y equals 24. Y equals negative 8. So I have 3 points, and I hope they're going to line up. When x is 0, y is negative 4. When x is 3, y is 0. And when x is negative 3, y is negative 8. So yes, indeed, I did that right. There's my ruler, there's my line. So what happens if the equation isn't quite standard form? So remember I said that your a value needs to be non-fraction. None of them can be fractions. Well, we use our algebra rules. I'm going to multiply everything by 3. And that's going to give me the new equation, but same equation, 2x plus 12y equals 12. And that's what I'm going to use from now on. I'm still going to use when x is 0 and when y is 0. So when x is 0, that's 0. So I have 12y equals 12, so y is 1. When y is 0, that's 0. So I have 2x equals 12, so x is 6. And I'm going to pick x negative 6 because I like that trend. So now I go 2 times negative 6. Remember, you can pick anything, but this is a good strategy to take. I suggest you do it. And now we're here. So now we have negative 12 plus 12y equals 12. 12y equals 24. Divide both sides by 12, and y is 2. So here's what my line should look like. x 0, y 1, x 6, y 0, and x negative 6, y 2. Perfect. There is my very shallow, not so steep line. There we go. So let's do another. So here we go again. This is definitely not what I would call standard form. So what am I going to do? I'm going to multiply everything by the lowest common denominator, which is 6. And I'm going to get 3 times 1, so 3x. And then here I get 2 times 2, so plus 4y equals 12. So I'm going to go x0, y0. And then when x is 0, that's gone. So 4y equals 12. So what's y? Y is 3. And then when y is 0, that's gone, right? So 3x equals 12, so divide both sides by 3, and x equals 4. So boom, there's 2 points. And now I'm going to pick x equals negative 4. So 3 times negative 4 plus 4y equals 12. Negative 12 plus 4y equals 12. Again, I'm going to add 12 to both sides. This time y equals 6. So what does this look like? Well, when x is 0, y is 3. When x is 4, y is 0. And when x is negative 4, y is 6. And again, my line looks great. So I haven't screwed anything up, and I'm good to go. So standard form isn't as helpful as slope-intercept form, but we definitely can work with it. Particularly, it gives us our x and y intercepts, which are 2 great points to have. Now, the other thing we can do, though, is we can use algebra to convert from one form to the other, because if you like slope-intercept form, just convert your standard form equation into slope-intercept form. And remember, slope-intercept form, we're looking for y equals mx plus b. So we want y by itself. That's our algebra goal here. So what am I going to do? I'm going to subtract 3x from both sides. I'm going to get negative 4y equals negative 3x. I put this first, and then that's a plus 6, so plus 6. Just rearranging the order I put those numbers in. And then I have to divide everything by negative 4, and I get y equals positive 3 over 4x because those cancel, but then minus 6 over 4, which is 3 over 2. Now, here's slope-intercept form. Do I have a lovely y-intercept? No, it's 1.5, but whatever. I do get my slope out of it, which is super helpful, 3 over 4. So the conversion can be super helpful. So now this next one, you might be tempted to get rid of all the fractions, but let's not worry about that because all we need is y by itself. So first let's add 2/3 x to both sides. And now we get 1 over 4y equals 2 over 3x plus 7. And the reason why we didn't get rid of fractions is because we're so close, because now all we have to do is multiply by 4. But then we have to multiply by 4, and you get y equals 8 over 3x plus 28. So you now have your slope and your y-intercept. So that one's awesome because it's really easy to graph now. So there are benefits to algebra. Here it comes again, right? Now what about going from slope-intercept to standard? Well, the first thing to remember with standard is that we do not want any fractions. So in these scenarios, let's just get rid of all the fractions right away. So for the first one here, I'm going to multiply by 3, I'm going to multiply by 3, I'm going to multiply by 3. And that's going to give me 3y equals 2x minus 12. Now, remember, in standard form, we want the x and the y on one side and the number on the other side. But we also need our x value to be positive. And here the 2x is positive. So rather than get rid of it, I'm going to subtract 3y from both sides. But I know I don't want the negative 12 over here because it's going to need to be on the other side. So I'm also just going to add 12 to both sides kind of at the same time. So what I get is I get 12 over here because that's 0. And then equals 2x minus 3y, because that's 0. And that is standard form. Don't freak out. That is exactly the same as this. I've just written it backwards. Be okay with that. And now our last one, I don't want fractions, so I'm going to multiply everything by 3. And I get 3y equals 15x plus 2. And again, this is positive already. So let's get rid of the other things. Let's move the other things. So minus 2 gives me 0 minus 2. So now 3y minus 2 equals 15x. And then I will minus 3y, 0 minus 3y. So negative 2 equals 15x minus 3y, which is exactly the same as 15x minus 3y equals negative 2. And we're all good there because now we are in standard form. So algebra can come in handy there as well. So that's it. That's standard form. We learned 2 more forms technically in grade 10, but this is just the start. And we have 1 video to go. So great work. I know this one has a lot. It's got all your algebra in it. So this one's going to take a lot of practice. Don't shy away. Keep hammering away. Good job.